Okay. So the lecture today is divided into two parts. The first part is me talking and kind of waving my hands. And the second part is you actually trying out things for yourself. So what we are doing today, we are trying to increase our workshop, our vocabulary in terms of tools by using what's called command line programming agents. I'm not sure if you have already experience with it or not, but at the end of this class, you should, because the lab is about using them. So what is it all about? Let me make the slides clickable. All right. So you are probably familiar with like Copilot and some of the code completion AI-enabled tools. And that is sort of the very basic AI assistance that you can get as a programmer. But you can also use AI as a sort of an active participant in your team, and you can delegate tasks. You can make it to pick up tasks from the issue tracker. You can make it integrated with your GitLab project, and then put comments into the GitLab comment sections and fetch tasks from your boards and kind of be a team member. And you can multiply it. So you, instead of a single AI agent, you can have multiple of those. And this is how many teams and many development processes already integrate AI in the development. And we have to get a little bit better at it. So it kind of helps with improving the quality of our code bases, improving the documentation. It also improves the process, because those AI agents are a little bit dumb, and you have to be very precise what you want them to do. Otherwise, they will go a little bit sideways. So the process of like developing software, if you have only humans in the loop, is a little bit less strict, because you have a lot of verbal communication and sort of rules, and you have a certain expectations, like human expectations. So if you are working, let's say, with 3 other people, you know not to do certain things, or you know not to delete tests, right? But if you throw in an AI agent into your team, the AI agent will delete your tests. Like if the tests fail, the easiest, the easiest task or the easiest activity to help making all tests pass is to remove the tests that fail, right? You as a human, you would kind of never do it, I hope, but the AI agents often do that. I often have those experiences where a test fail, we're trying to fix it, and then eventually the AI agent sneakily removes the test or changes the test. It's like, no, 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 no. Like we have to fix the code, not fiddle with the tests, right? So because of that, you have to have a more strict process. You have to actually write down all the rules and all the things that you normally keep in your head with other team members, because as I said, the AI agents are quite dumb. How to do that? Well, there are many ways to doing it, and the benefits are that you have your development process a bit more strict, but also you don't spend time on a lot of boilerplate and mundane tasks. You're actually focusing on more strategic elements of your development, and all the mundane boilerplate things are being taken care by the AI agents, which actually feels really nice. So if you get yourself organized well, and if you have your process done well, it empowers you. It actually makes you be more efficient and more productive, and you can focus, as I said, on more strategic elements of your project instead of the nitty-gritty details, which is really nice. So before we dive into the mechanics, I want to kind of spend a little bit of time about the becoming an expert and perceptions the society has and you have on things, right? So once you become an expert in something, you see all the details, you see all the scaffolding, you see all the mechanics, and then some of the magic kind of goes away. I had a supervisor in my school years who came into IT from physics and then through filmmaking. So he finished like a film school. And he often talked to us about filmmaking and how the films are made and how different tropes are used in films and what film elements are being used and so on. And once you know it, once you know how to cutting of the scene is happening and so on, you see movies in a different way. They a little bit lose this sort of magic because you see the mechanics of how the editor is kind of cutting the scenes, how the sound system is sort of interleaving the scenes and so on. So it is not only in tech, it's in every domain. Like once you become kind of a bit of an expert, you're seeing details which a non-expert don't see, right? And it's obvious. And you know exactly how things are done, what techniques are being used. So if you're not an expert, you usually see the finished result, and you're kind of usually amazed but how things work, right? So there is an effect where experts underestimate their own field and overestimate the fields which they are not experts in. So a simple example is like if I read an article about paragliding, I see all the problems with it. Like I see all the assumptions and all the wrong assumptions and all the mistakes and all the simplifications. And then I turn the page and I read about growing avocados and it's like, wow, it's amazing. I want to grow avocados at home and so on, right? Because I don't see the details. I'm not an expert avocado person. So I'm kind of glossing over all the details. So we have to remember that effect, and we have to apply the same strict rules to the domains we are experts in and the domains we are not, because the mistakes are the same, like the simplifications and mistakes and so on are the same, right? So if I read an article claiming, oh, there is this new fancy framework, it's like, no, the things that this framework claims have been in Haskell for 20 years, right? There is nothing new here. And I see that. But if I read an article about like field I'm not expert in, like quantum encryptions or something, I was like, okay, that sounds reasonable. Like I'm convinced, right? But the same mistakes are there in here and there. It's just that because I'm not an expert, I don't see them. And remembering it, it's quite hard. But we have to train ourselves to be kind of skeptics in the fields which we are not experts in, as much as we are skeptics in the fields we are experts in. It's obvious, but we all fall victims of this sort of effect, right? So it's called Gell-Mann amnesia effect. And the very good example now is the AI hype, right? So with expertise, you're becoming kind of a more attuned to the details and to the mechanics of how things work. So once you learn something, you see all the nuances and all the details. If you're not an expert, you gloss over it and it's sort of you don't actually see it. So yeah, by the way, all those slides are a little bit wordy. They have been generated by AI, and I've checked to remove all the mistakes and simplify it, but I don't really like the slides. Like they are a little bit wordy, right? But they are kind of good for review. So they are kind of left here. Like when you kind of reviewing it, it's good to have more text because you don't have to take notes. But if I were to make all those slides, they would be much more compact, right? So then there is this sort of balance thing. So in Zen, in Buddhism, there is this saying of like a beginner's mind. You always strive to have this beginner's mind, right? So from one hand, we're striving to be experts, and on the other hand, we are told, no, you should be the beginner, right? What is it all about? Well, it's about finding balance, right? Because if you become an expert and if you sort of see all the details, you're narrowing down your mind and you don't see the possibilities of what could have been, right? So like if you became, let's say, a C++ programmer, you're really good at C++. You lost the ability to see that things can be done a different way. They can be done in a different way to C++, right? So you have to kind of open your mind and be a beginner again and say, oh, I kind of want to learn more about programming. So it's sort of finding the balance between being very good and kind of expert in something and being a little bit open-minded on different views and kind of opportunities which are outside of your expertise. And it requires a little bit of again, it's not a very natural thing to do, because it requires you to go outside of your comfort zone, right? So we feel confident and we feel good at things that we know and we are familiar, that they are familiar to us, but things that they are not kind of scare us and they make us vulnerable. And it requires us to say, yeah, it's okay. It's okay to be vulnerable. It's okay to not know something, because that expands our mind and like makes us better in this beginner minds kind of situation, right? So it's about the balance, like becoming an expert, but at the same time being open to things that we are not experts in. Again, it's obvious, but it's good to remind ourselves about it, because as I said, we tend to dive into things that are familiar and make us less vulnerable, but we have to, on purpose, make ourselves more vulnerable. All right, so then there is this AI kind of nonsense going on, and like um, what non-experts see is that magic is happening, right? AI can write code, AI can do this, can do that, and so on. And to non-experts, it feels amazing, right? And to experts, it's not amazing. It's just like a tool with limitations and strength, and then we can use it. So we see more, experts see more details, see more edge cases, see more nuance, and they can make more informed opinions. Non-experts don't gloss over it, like they don't see any of that, right? Many people, when they talk about AI, they don't see a difference between LLMs and machine learning at all. To them, it's like AI, it's this black magic box which can do things, right? And of course, there is a huge difference if you are working with large language model or if you're working with a model built on a different data using some machine learning techniques. You will have you will have a machine learning course next semester, I hope. So you'll kind of be a little bit more you will gain more expertise into differentiating and like finding limitations and strengths. But in here, we just kind of discussing in general that there is this discourse between hype and non-hype, and experts and non-experts discussing something, right? And our goal is to move from perceptions and kind of intuitions into actual knowledge and informed practice. And AI is amazing. It is amazing. Like it can do certain things that have not been possible before, but it also has its limitations, and we need to understand what those limitations are and how to work with those limitations. So we have to, as I said, make it work for us, but at the same time, not to be over optimistic in certain situations. All right, so being old also gives us more perspective, and being young kind of gives us less perspective. And then being old kind of makes us see certain patterns. And the hype cycle is very clear. And the good thing is that hype cycle has accelerated, and we have seen many hype cycles in the last, let's say, 10 years, which are kind of obvious. So I don't know if you remember it, but maybe 15 years ago or 10 years ago, there was this really big hype about augmented reality. We thought, you know, Google glasses or Apple glasses will take over the world. Everybody will use it for everything. Like motorbike riders will use it, like drivers will use it, and so on, right? And it felt amazing. But then it turned out, yeah, you know, it's okay. I mean, if you are a driver and you have it kind of display on your dashboard, it's okay, but it's not that necessary. If you're a jet pilot, a fighter jet pilot, yes, it's good to have kind of a lot of augmentation in your helmet, right? But there are some niche domains. So basically, in niche domains, it kind of finds its way, but in mainstream, it turned out to be not that great, right? VR was the same. I've heard stories about, you know, everybody doing virtual classrooms and virtual meetings because physical is gone. It's like caveman kind of style of meetings. It didn't happen, right? The virtual worlds are there. Again, it became a bit of a niche. When COVID happened, yes, we had a lot of online meetings and so on, but not really in virtual worlds. They add extra glitches and extra things. So again, it's sort of great for gaming and simulations of certain niche domains, but in mainstream, it didn't really change much, right? Blockchain, very recent one. A lot of people believed it's like a revolution, it's gonna revolutionize how society works, how we build trust, how we can put certain rules into protocols and into code, and then change the way institutions and organizations work. And it happened to some extent. So we do have some organizations, there are some movements, like for example, open science, which rely on blockchain technology to achieve certain things. But again, mainstream, not much changed. Niche changed a lot, right? So now we are kind of in the LLM AI kind of hype, and people say, yeah, you know, it's gonna change everything. It's gonna change how businesses operate, how institutions operate, and AI is gonna take over all the jobs and things like that. Yes, you know, looking into the patterns, I would say, yep, it's gonna change some niche domains, and some niche domains are gonna really benefit from it. Mainstream probably not gonna have huge impact at all. So we will see. Like we are in that cycle right now, so it always goes into overhype, over promising, and then disillusionment, and the actual productive use. So what we want to go is to go into this effective productive use right away without all this kind of hype. So yeah, it's kind of interesting. There is a lot of memes and discussions going on, but you know, stay skeptical and try to use it as much as you can and build your skills. And then it is definitely helpful for programming, but I doubt it's gonna kind of wipe the industry completely from humans. So all right, so let's go to the mechanics of how we're gonna use it. So code completion, as I said, you probably all experienced it. You know how it works, what it is good at, what is it not good at. One thing that has improved is the context. Before, the code completion tools were not able to see all your code bases. Now they kind of see more, so they became a little bit better, but they have some limitations. And code completion as such is not new. I mean, we did have code completion for many years already. It's just a little bit better code completion, right? So there is not point to talk too much about it because you're all familiar with it. It existed in many integrated development environments and IDEs. So it's just a better version of it. And it's obviously it's useful. Is it useful when you're learning? It's an old debate, like, should you learn programming using IDE, or should you use, like, you know, Notepad or Vim without the IDE to kind of type everything yourself? I think you should type. But you know, with the modern tools, we typing less, right? We typing less code and so on. So maybe some of the skills that were needed before are not so important anymore. And you can build your mental understanding without kind of muscle memory. But I'm old school. I like my muscle memory. So, you know, I still promote doing the muscle memory practice. But I don't know, like nobody knows. Like, so maybe you don't need to do it. Maybe just reading it, like doing it like visually and working with the code bases is enough. We will see. So then the best practices, of course, you have to review all the suggestions. You have to help AI with the context. It often helps with the code completion to have some comments or proper named variables and things like that. It always helps. AI is surprisingly dumb in terms of renaming things to be something that don't match what LLM was trained in. So let's say you have like if you have some like some function like I don't know, fetch data, right? And then it is called fetch data. It has kind of a English components, and then it's used in the context of your application. and then you ask the LLM to sort of help you, like fixing some bugs or doing something with this function, it will be actually quite good. But if you name this function A, okay, it's a very generic name. It has no context and it has no association, but like for the human, it's exactly the same. I mean, I know A is doing fetch data is kind of the same, but for LLM, it's not. Because of the biases of the training data and everything else, this is much, much, much better. Of course, for humans, this is better as well, right? But if I tell you, yeah, we named fetch data A, you will be able to work with it quite efficiently. LLMs are not that great. So if the names are confusing, if the names are sort of not what the mainstream sort of data sets are about, then LLMs will suck, right? So it is in your favor to make names kind of meaningful, English, descriptive, such that it will help LLM to work with it. All right. You should never accept large chunks of code without understanding it. And then you should never skip tests. But that applies to all the use of AI. It applies also to the use of your colleagues and your teammates in the team, right? If the teammate kind of makes a pull request, you don't just say, yeah, let's approve it. You say, yeah, does it pass the test? Does it pass the linter? Does it work? Like, does not break all the regression tests and so on. So we apply the same logic for AI as we apply for humans, but we are more strict with AI. All right, so then ideal case, blah, blah, blah. We probably should not do so much code completion work. We should focus on the kind of agentic aspects. So I'm kind of skipping a little bit the first two parts. So then there is a chatbots. So chatbots was a little bit new interface. Instead of you typing code and the code completion happening in your editor, now you have a separate window where you can kind of chat about the code or about what is happening with some form of LLM. And there are some tools which you can use, and it's really good for understanding. It's really good for explaining and for synthesizing things and for working with text. So if you have a large code base, you can do some analysis of the large code base yourself using IDE tools. You can find how a certain function is being used and so on. And we had it before as well, but now we have much more meaningful and sort of a human-like interaction. You can say, is this like a single responsibility class? How is my class being used in the code base? And do I break like a simple single responsibility pattern? And it will analyze the code base and it will tell you, right? Most of the time, it's actually doing a good job. So most of the time, if you have to analyze the code base and kind of infer some information, how some things are used, it will do decent job. So for code reviews, for suggestions, for architectural designs, for things like that, chatting about your code base with some sort of bot is very productive and very helpful. You should never fully trust it. So it can make mistakes, but most of the time it's like it actually is pretty good. So you can do some architectural questions. You can ask, okay, I'm building this Go web service and I need to fetch data and blah, blah, blah. How should I organize it? What layers should I have? Things like that. And it kind of does decent job. Where it fails is if you're doing something a little bit outside of the mainstream, which is not work as usual. If your work is as usual, it will do fantastic job. But if your work is a little bit off, if like, let's say you're doing a tic-tac-toe game with some extra rules, like let's say we have a tic-tac-toe game and players make moves. So I make a move and then I say the next player can, instead of making a move, can cancel my previous move. So deletes my move, right? So we have a tic-tac-toe game with this new extra rule that instead of just making moves, you can also delete an opponent move and he cannot or she cannot repeat the same move, right? So if the first player played here and I said, no, you cannot do this, and the player played here, I can play here, right? But then the next player can cancel my move and so on. So the game becomes kind of different, right? So if you have cases like this, LLMs and the bots will lean towards the mainstream. There is so many tic-tac-toe implementations that your case will be like odd, and it will always try to push you towards the mainstream, right? And you will have to fight it. So depending on your case and depending on your how typical your case is, they will be either doing excellent job or doing kind of more and more sloppy job, right? To a point where it will try to convince you that your rules are wrong and the mainstream rules are better, right? So, but in general, as I said, it works quite well. So it will struggle if there is no project context, if the generic solutions are not what you're looking for. It sometimes have outdated information, so some API versioning and so on, that's a usual problem. And it typically, when you're chatting with the bots, they cannot really verify what they are saying. So there are two ways to deal with it. So once we move to the agents, you basically make the agent run the tests and check if it actually works. So it can be part of the workflow. Or you can have a chat workflow where you're chatting with one bot, it gives you some content. Like, let's say you ask a bot about this architecture, right? And it said, okay, you should do this, this, and this. You should have those layers, blah, blah, blah. And you said, okay, put it into a markdown file in my file system. And you have it there. And then you take this file, you give it to a different agent, and you say, be a critic and find all the problems with this design, or how can we improve it, right? So you can have like a second bot helping you evaluate the first bot answers. And people do that. So they have multiple roles and they pass sort of like a certain suggestions through multiple things to really improve the quality. And every time you do that, it helps. I often ask a bot to give me like URLs to something to find me sources for stuff. And then I have another bot says, now given the list of those sources, verify if they are actually real. So a lot of like sources are hallucinated, they don't exist. And the second bot will find it because the second bot tries to actually find them online and check if they are real, right? So then if you have this two-step process, it really improves your quality. Right. So then the final one is the coding agents, and that's the gold. That's what you want to be using, right? So as I said, if you haven't used it before, you should try now. And they are different. So they are different to code completion and they are different to chats because they are actively messing up with all your files and all your code base. And they are able to use tools like Git, GitLab, editors, all sorts of compilers. They can run tests, they can check what the test outputs are and so on. So you can organize your work as if you had a teammate, right? So you can tell it, read issue 23 from GitLab, prepare a plan, put the plan into comments, execute the plan, check if all the tests pass, write missing tests, edge cases, and so on. So you can actually organize the work in a very long chain of actions, and the coding agent will do it for you, and then you will have the result, right? There are two types of coding agents. There are guided approaches, and Anthropic and like Cloud Code or Open Code, they follow this guided approach where you have a programmer or kind of a driver sitting and guiding the whole process and reviewing every step. Or you have this kind of hands-off approaches where it's more like vibe coding. Like you actually don't care what code is generated. You're just saying, do this, do this, do this, but you don't take ownership of the code base. You don't know what the code base is and you don't care. You just care about the effects and the results, right? So they both have strengths and weaknesses, and we usually go with the guided one because we want to maintain the ownership of the code bases. So it's sort of like a part of the team. It's a collaborative programmer, which does a lot of things for you. It's not just code completion. It's not just chat explaining things and so on. It is actually doing things actively on your code base. So it's really good for larger projects. It's really good for boosting your productivity and making you more productive. It's good for work as usual, for all the boilerplate, but you want to stay in control for the guided approach, right? For then, yeah, there is like an example. Adding configuration files or doing stuff in the code base and so on. I'm not gonna go through the examples. We're gonna do that ourselves in the practical aspect. The main point is that you guide each step, and at each step you make decisions and you sort of approve or don't approve, and you fine tune things, right? So if you say make a plan, you will see the plan and then you'll say, yeah, don't do step number 2, do this instead, and refine the plan. And then you have a new plan and then you move on, right? So you have sort of like a step-based approach where you're sitting, you're sort of watching the progress bar and you're sort of interacting with it occasionally when it needs sort of your feedback, your choices, or your guideline. So what do you do in the meantime? So it is kind of an interesting psychological pattern as well, because it's sort of like working with a partner and you tell the partner what to do, and now you have a little bit of time. While the partner is doing it, you actually have a little bit of time, right? So what I usually do is I'm reviewing like the issue tracker logs, the bug fixes. I'm planning kind of a new task for the bot, for this bot, for the new bot, and so on. So there is sort of a meta activities that you have to carry on, but you have to context switch. You have to go back to this guy and help him or her to sort of finish it, or help it to finish it. So this context switching is a bit painful. So some people cannot do that. Like some people find it kind of a little bit tricky to do this kind of context switching. So it depends like how you train yourself and how you will work with it, right? I don't know, like it probably is a little bit person dependent. Some people just, just chill out. They do nothing, they wait. I sometimes do that as well, especially if I'm a little bit tired. I just wait. Usually it's like seconds, but sometimes it can take like up to 2 minutes or something, right? And then you feel you're wasting time. So my mind drifts and I'm watching some videos or something, right? So it depends, like it depends, on you and how you organize your work. But there is this kind of effect that you have to wait for the tools to finish. So so many teams, to optimize it, they engage multiple agents. So you basically engage multiple agents doing multiple things, but as I said, you have to context switch, and that takes a bit of a toll on you. All right, so then hands-off approach, there is minimal interaction. You're just giving the kind of a bigger picture thing of what needs to be done, and it goes into cycle. It like makes some code, compiles the code, runs the code, checks the tests, fixes things, and so on. And you're not involved. It is sort of doing it on its own, right? I try this approach with Codex, and I don't really like it. Simon, he loves and he uses the Codex much more, and he sort of likes it. But I feel I'm losing control over the code base, and often it drifts into the region which I don't want it to drift. And then going back is really hard. You end up with a lot of refactoring and a lot of problems because it's sort of goes out of your rails, right? But if you have a very boilerplate heavy workflow, or if you're working with tests or test frameworks which are not your core logic, then it's fine, because then you don't spend time waiting and kind of guiding it. You can leave it for hours and then come back to it like the next day or something. So this is like a summary table. We have this cloud code kind of approach, or Codex approach, and the interaction load is quite high for cloud and quite low for the hands-off approach. you decide most of the things. Here, AI decides. So here you have to be more strict about specifications and rules because you have to limit the decisions. You want to limit the AI decisions to just non-important ones, because if it makes a important decision wrong, then the whole thing is screwed up. So here you are more in charge. Here you are more in charge in all levels of decisions. You are slower, but you're still more productive than not using a coding agents at all. So you are slower, but you still feel empowered and you still get a lot of work done. Here it's faster. I get a feeling that it is faster, but it takes me more time to fix things that get broken later. So overall, I think I actually am more productive with this approach. But again, it sort of depends on the task at hand, how generic or how work as usual it is. If you're building some crude application, create, read, update, delete kind of backend service for some data, yeah, this is perfect for hands-off. Like, work as usual, nothing fancy. There is not so many things can go wrong, right? But if you're building this sort of, innovative tic-tac-toe, hands-off, yeah, you're probably gonna get beaten badly. So it depends on the nature of the task, which one is better. So with the guided one, you learn a lot because you're part of the loop. So you yourself kind of get to know a lot of tricks and a lot of things. With the hands-off, you don't learn much. So this is sort of like when you're doing vibe coding, you don't really learn a lot about coding, right? But if you're doing this hands-on approach, you learn about coding yourself, even if you're using like language or something that you're not so familiar with. You have much better, hit rate. So your code base will do what you really want it to do. Here, it's kind of hit and miss. As I said, I tried those approaches and I didn't like it because it was difficult to get what I wanted. And with these approaches, you almost always get what you want. But for example, if you want to generate like a generator for your data files, again, if you give it a specification of what the file should look like and what the data should be like, there is not so many things that can go wrong. So maybe going with this is fine, right? It's not a mission critical. It's not like business logic critical. And then you get a tool to help you with something. I actually did that. Like I built a tool for doing some statistics on a Git repository for grading projects. And I did it this way. And then I had to verify that the results were correct manually, and it worked quite well. So again, it depends on the nature of the task. So vibe coding, like this one is a bit low, this one is quite high, and then code ownership, this one is high and this one is low. So it's a spectrum, right? It's sort of where you give up your control and you gain flexibility and speed, and where you keep the control, but you're a little bit slower and a little bit more hands-on. So, all right. A little bit about workflow organization. So as I said, working with those coding agents is important to be organized well and to have your project structure organized well. So having all those markdown files and specifications and like what to do and what not to do, it has to be written down, because every time you start the agent, it has to read all this knowledge from somewhere. It does not have memory, right? So you are the memory. All those files are the memory of the agent. So every time a piece of work is done, you have to document that it was done. Otherwise, it will think it's not done and it will try to fix things that are already fixed and blah, blah, blah. So it's quickly going to be a mess if you're not well organized. But if you are well organized, if you have a project overview, how to set up the project and so on, if you have the design decisions, if you have your overall goals in the architectural MD file, and then if you have some sort of additional context and additional files, and you bootstrap your agent and you say, please read those files first, and then do this or do that or become that role, it will be much better. So you have to be this. You have to organize your workflow around markdown files, and kind of specifications. Do you have to write them all by hand? Of course not. You can use the bot to write them for you, right? And also you can use the bot to update them for you. So every time something changes or every time you make a different decision or different conventions, you can say, yeah, please update it in the convention files. So you can keep all those files up to date by the bot, and you can initially bootstrap them by the bot as well. But then you have to read it, remove all the fluff, and as with the slides, the bots tend to be a little bit wordy. They like to kind of generate a lot of tokens, a lot of text. You sometimes have to be more concise, and you can tell it like, be more concise, be more like remove redundancies and things like that. But even then, like, your input is important. So you will have to read those files, and you will have to kind of organize it such that it works for you. And then you have the specification files, and doing this sort of like checkbox to-do lists, or having those sections with clear titles and like bullet points is a way to organize it well, right? Setting up the limits of how things are and like putting the specifications in is, of course, is important. And then making the some decisions of how the architecture looks like and so on is also important. It gets a little bit of getting used to, because a lot of this happens in our heads and we tell it to our team members, or if we don't have a team member, we just remember and we never write it down. But now you have to write it down. Like everything that you have in your head, you have to write down, right? Which is both a little bit tedious, but also a little bit good, because if you come back to the project or you need to onboard a new member into the project, suddenly they can read the docs and like it's obvious, it's all there, right? There is no like misconceptions. So it adds a little bit of an extra work, but gives you a lot of benefits. So it's worth doing it. So write the specifications with the help of the bot first, and then tell it to write tests. So you always need to have tests before you start implementing anything, because once it's implemented, you have to check if it passes the tests, right? Why? The bots are clever, and the bots have the same biases as us. If we write code first and then say, now write me tests for this code, it will only write tests that pass. It will not be able to come up with a test that fails your code, because it already has the code, right? So if you have a specification and now you say, write me tests for this specification, but the implementation is not ready yet, it will have to write tests following the specification, and then it will have to write code following the specification, which pass the tests, right? So it's more logical. And then let the AI implement the code to pass the tests, and then you verify that everything is correct. As I said earlier, you have to watch out for the bot not deleting your tests. They do like to do that. I had a fun refactoring exercise. I had some Golang files. So so in Go, I had some business logic, and I had some structs with methods, right? So I have some structs with methods, and it was working fine. And I had tests for it, but it was becoming a little bit unclean. And I wanted to extract some of the interfaces such that the implementation implements those interfaces. So it's a kind of a simple refactoring, right? So you have the implementation. So the implementation was done, but I wanted the interface to be extracted from the implementation. So I told it, okay, follow all the structs and extract the interfaces that those structs implement, right? So it kind of did that. So it did this kind of refactoring. And then using those interfaces now in the code, instead of concrete structs, we're gonna use the interfaces instead to make the code more, robust. So it did that as well. So it did this to, instead of using implementation, to use the interfaces. And then it was the case to pass the tests, right? So now we have to update the tests and all the tests have to pass. And after this step was a little bit wonky. And then this step was really wonky because a lot of tests fail, right? So a lot of tests were failing. And then it first tried to delete the failing tests. So I prevented it. So then what it did, it instead of changing the way this step worked, it updated my implementations after updating the interfaces to pass the tests to be a different business logic, right? You see how it tried to trick the whole process to pass without actually understanding that this is the core business logic. It cannot be changed. All we're doing is just refactoring what this is the ground truth, right? But normally what happens is it starts with specification, it generates the interfaces, and then based on the interfaces, it generates the implementations, right? So once it had the interfaces, and modify the interfaces to actually fit the test and the test make to compile and so on, it tried to modify this. And it was like, what are you doing? Like, you messed up all my business logic, right? Just completely like a broken model, mental model. So you have to watch out for gotchas like this. Like, if you don't, like, if it was hands-off approach, it would completely derail the whole refactoring. But because I was in the loop and I could catch it immediately and then say, no, this is like, you never touch this. You never modify my implementations. This is the ground truth. Everything else has to be adapted, but this, you don't touch it. So as I said, normally, if you're starting with a project which is empty, what you have is you have specifications, and then you generate interfaces, and then you implement the interfaces, and the workflow is as this. You should have the tests first, which are sort of matching with the interfaces. All right. So let's have, let me see, what else do I have to talk about? All right, so role-based prompting. So let's have a break. Let's have a break, and then I will talk a little bit about more advanced prompting techniques and how we organize the agents. And then I will give you time for playing with the two coding agents, which are for free. All right, so any questions for the first part? All right, so let's have a break. Hello.
The mandatory assignments.
Okay, just give me a second.
Yes.
I will do that and stop the recording. So, role-based prompting. This is a technique which is used for all possible interactions with the bots. Either you're doing it in the chat or you're doing kind of a code completion by the comments. You're basically priming it to assume a certain role, assume a certain kind of characteristic. The most important two modes. So the way, like, yeah, so far we kind of discussed it a little bit abstractly, but basically what happens is you have your C drive, and then you have some folder structure, and then you have your project, right? You have to give the agent access to a particular location in your file system and all the subdirectories. So it goes like, if you give it access to C, it will see C and everything that is in C. So you should never do that, right? Some people are very paranoid and they only run coding agents inside virtual box or virtual environment, such that it limits the possibility of leaking information. But all the commercial tools and all the tools that we're gonna use, if you tell it not to look out of the parent folder, they will not. So they will kind of, if you are here and if you give it access here, they will kind of be able to read everything from here, right? But all the subdirectories, you cannot limit how deep it goes. So what is the best strategy is to sort of set up like some sort of a project folder and then have a project for like P1 and then go with your bot here and say, okay, this folder is what you can see and what you can work with, and then, you know, do stuff here, but don't look anywhere outside of that folder, right? So the two roles that we usually work with is plan or implement, right? So in plan mode, they will read only and they will provide plan of what to do, but they will not actually do stuff inside your file system. In implementation mode, you're giving the permissions to write files and to modify files. So the plan mode is often very useful before something happens, so you know what's going to happen and how it's going to happen. The implementation mode, of course, can be split into multiple implementation modes. Like, for example, you can limit the documentation only. So you can say, okay, you can modify documentation files, but don't touch my code base, right? Or you can kind of say, okay, you can touch my code or whatever. So this is like up to you. The plan, of course, is up to you as well. And with the plan, what you can do is you can also maintain like a, let's say, plan.md file, and you're not only reading and kind of interacting with it in a form of a chat, you're also saying, okay, prepare a plan and then write it in here, right? And then you can modify it, you can edit it yourself, and then you can say, okay, reset the context window, reread this file, and then do stuff, right? One gotcha that often happens is every time the bot generates something and you modify it, in the context window, they don't see your modifications. You have to ask it to reread your files. Otherwise, it will think it's the old file. So you always have to remember it. So either reset the context window or say, please reread this file again, right? So this is how like it works in a very high level. Then there is one more aspect. So if you have your disk, and you have your sort of, you have an agent kind of messing up with your disk. The agent needs to talk to an LLM. And then if this is your laptop, you can have a local LLM, which the agent talks to, and then the information never leaves your computer, right? So it's very on-premise kind of situation where your information is very private. And in this situation, if you have this use case, you may give it access to your C drive, right? Because the information from a C drive never goes anywhere else, right? So in that case, yeah, maybe for reading emails or for doing something kind of a more intimate with your data, you can kind of have it. But you have to make sure that the agent is only using your local LLM on your laptop, right? Normally, what we do, you can configure it this way, and some people do this way, and they use some open source smaller LLM models which are able to run on your computer, but they are limited. Like to some, they will be okay for some tasks, but for some tasks they will be a little bit limited. So it's a little bit like let's say less intelligent. So if you go to the internet and you allow your agent to talk to LLM from somewhere else, like from Anthropic or from Google or OpenAI, then the information which kind of lives in your computer leaves your computer and goes to US or goes somewhere, right? And this is the security threat that you don't want some of your information to go out there. That's why you have to limit it to only the project that you're working on and only the folder that you really want to, or the container or the sort of a virtual machine that you're working with, such that this leakage of information which is private to you can happen because of this agent asking LLM stuff, right? Those LLMs tend to be better. They tend to be a little bit more intelligent and less annoying. Those are better for security situations. So if your code base is very private, you cannot expose your code base outside of your organization, or if you're working with your emails or some personal data, obviously you don't want this model. You want this model, right? But if you're working on a school project and nobody cares about your, snake game, then of course you can do this, right? But you have to say, work only in my snake game project. Don't touch anything outside, right? In the real world, a lot of organizations, they have very powerful equipment and infrastructure that they can replicate a very powerful LLMs locally on premise, and then they can use it this way, right? We do have a little bit similar situation in NTNU, and for next week, I didn't prepare the instructions yet, but I will try to help you set up your agent to use the NTNU LLMs, which are more powerful than the ones you can run locally on your laptop. And they are sort of matching the ones which we're gonna use for the exercise, right? So for the exercise, we're gonna use Gemini from Google because it is for free and you can use it just with your personal Gmail account. But if you want something more secure and more local, then there is this third option where you instruct your agent to use this NTNU LLMs, and then the information will go like from your laptop to NTNU servers and back, and they will be kept within the NTNU network, and it will not leave outside of NTNU. So for some projects, that makes more sense. For some throwaway projects, this is fine. And for learning, this is fine, right? So for the exercise, we're gonna do this. We're gonna use Gemini, but I'm telling you to remember that if you're using Gemini, your information that you're chatting about is leaving your computer, and the agent can access specific things from the folder that you gave it access to, right? Any questions about this? Sweet. So now about role-based prompting. There are two aspects to it. One is the role-based prompting in itself, which is we have to do it. And the second one is you can set up multiple agents having multiple roles and being orchestrated in a more complex orchestration scenario. And that's beyond the scope. We're not gonna do this. I mean, if you've really been using coding agents for a while and you want to try it out, then, go ahead. But it's more complicated. It requires more meta management and so on. So what we're doing is we talking about role-based prompting, but each role is invoked in sequence, and then you're switching from one role to another in sequence, and you only have one role active at the time. So you have one agent active at the time and one role active at the time, not multiple at the same time. What's the difference? Well, the difference is just complexity, right? Like how you orchestrate the whole thing and how you deal with the complexity of multiple agents talking to one another, right? Because you can have, you can see that what we're gonna do is we're gonna say, okay, we have the agent, and we're gonna say, okay, please generate the specification file. So it will write it as a spec, and then you can say, okay, now, so after the spec is generated, spec MD, let's say, you go back here and you say, okay, reset the context window, became like the analyst, read the spec, find duplications, whatever, improve the quality. Like, as I told you, like the loop twice, right? After you have the improved version, then you say, okay, wipe the context window. Now read the specification and become the implementator and generate the code base, right? So now we have the code, right? So we kind of iterating with multiple roles and multiple passes over the same agent iteratively in sequence. But you can automate this process even further and say, okay. I have the initial architect. So I have an architect, then I have the architect reviewer, and then I have the implementation agent, and then I have a testing agent, and I have whatever orchestration you say. And then you say, okay, you generate me the first specification file, and then pass it to this guy. This guy should read it, improve it, and pass it to this guy, and blah, 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 right? And then you kind of automating the whole interaction process for yourself. But when you do this, you sort of are orchestrating it and making it a little bit harder to be in the loop and follow up exactly what happens, right? So if you're repeating it over and over and over again, you may want this type of automation. But if you're doing it first time, and we're doing it for learning, we don't want to do this. We want to be in the every step ourselves, and we want to see what has been generated and how things have been improved and so on. So we gotta do this with a single agent over and over and over again ourselves, right? Because then we are in the loop all the time. Okay, so role-based prompting. A lot of talking before jumping into the topic. So you always need to say, what is the agent? Like, who is the agent? So you can say you are the senior software architect, right? Or you are the tester, or you are the specification writer, or you are a reviewer who is critically reviewing something, right? You have to set the role of what the agent is, and then the agent will try to follow the role. Because if you say, fix this code, yeah, that is a really bad prompt. It's does not give a context, does not give the role, does not give the what we really improving and so on. So you have to sort of say what the agent should become, and then what the agent should do and how it is being evaluated, right? So there are usually kind of some prompt suggested templates of how you work with prompts such that you get the best value out of the interaction. And the most important one is the role. So you can, for example, sorry? Yeah, so this is like a template where you say, act as a software systems designer, review this API design, and then you put the API specification in, and then you putting some constraints or some suggested actions, and then you say, yeah, suggest improvements. So usually, as I said, it's good idea to plan first and then execute the plan instead of saying, fix this bug, right? Usually what I do is I say, okay, you are the a code reviewer with such and such capabilities, and we have this bug, and then I point it to the issue tracker, like description of the bug. It can read the comments, the agents have kind of a tool integrations, and GLab is like a tool to interact with GitLab, and it can read issues and kind of fetch comments and so on. Of course, it can interact with Git. It can interact with your file system and so on. It can go and use curl to read documentation online and so on. So there is a number of tools the agent has access to, and you can kind of say, go online and find the documentation about this library, or what is the latest version and so on. So it can go online and kind of fetch things for you and prepare like a summary and so on. So you have to remember that it's not only about the code, it's also about automating things like this. One thing that I used it initially for is for like Git commits. So you could say, okay, I did a couple of changes in my code base, group them by logical changes, and make Git commits per logical change, right? So it says, oh yeah, those two files were changing like the login structure. Those two files changes were about this bug fixing and so on. And it was trying to do that. And then it tried to sneakily say generated by Cloud Code or something, right? So it was always kind of sneaking in some extra things. So if you let it do it without checking, you can get some undesirable effects. Or it was writing really lengthy kind of comments about like the Git commits messages. So you have to be quite specific, and you have to say, okay, Git commits have to have a short sentence with a dot highlighting the changes, and then a very short references to issue tracker and things like this. So you have to be, as I said, quite precise to get the best value. Okay, so the role one was the designer. Role two is the architect, right? So as a senior software architect, do some designs like current architecture uses this, propose like a package structure or like layout of the architecture, things like this. Testing strategy. Same. Yeah, we're gonna talk about testing in a moment. So then you have the implementer. So implementer reads the specs, follows the architecture designs and everything, and then actually writes the code, right? So that's the implementation stage. And then you always need to say, use idiomatic code patterns, use clean coding, use standard library wherever possible. I always say, ask me about external dependencies before using them, because it throws a lot of external dependencies by default. Because as I said, it's trained on a number of projects which are using a lot of external dependencies, and then you get a lot of unused crates or unused like libraries which like you need to maintain and so on. So it's really good to limit the ability to use external libraries, and then if you have a coding style, tell it where to find it. If you have a linter rules, tell it where the linter rules are also, and then make sure that after the code is generated, it sort of runs through the linter and the formatting and passes all the standards, coding standards that you have in your project. Okay, then you have a code reviewer. So after this guy implements stuff, you kind of ask, okay, now review it. Like how can we improve it? What is not idiomatic? What is wrong? Like, can we make use of better patterns and so on? So as I said, usually 2 passes is much better than the single pass. And then checking the test coverage and performance concerns often indicates that certain things can be done in a more efficient way. All right, so then for tests, it is also useful to not say, write me tests for this code. I explained that already for you, that once you have the code, it will create really stupid tests just to pass the tests. So you have to create the tests first. How to create good tests? Well, it's good to identify the edge cases and say, okay, read the specification and identify the edge cases for the data, for the user inputs or whatever, right? Once you have all the edge cases, now you can say, now write me partitioned tests, unit tests and integration tests for all the edge cases. And then you really have a good test coverage. And then once the test coverage is done, you can review the tests. And then, of course, they may not compile yet or they may not pass yet. That's okay. That it will come later. So the cycle is you get the tests. So you have tests written first. Oh no, first you have the specs, of course. So you have the specs, then you have the tests, and the tests don't compile yet, and that's okay. Often the agents, they try to compile everything they generate and run the linters and stuff like that. You also have to stop it. First of all, letting them run all the stuff consumes a lot of tokens, and you're gonna run out of your quotas if you let them kind of do everything for you, right? And second of all, you don't need to compile the code every single time the change is made. And as I said, like once you generated the test, they will not compile yet because you don't have all the interfaces and everything kind of implemented. So there is no point running the compiler on this yet. So then once this is done, then usually you kind of write, you implement some sort of interfaces or some sort of a generic logic, and then you have the actual implementation logic. Sometimes after this, generic interface layer is done, the test should already compile, because the tests and the implement interface logic usually abstract away the implementation details, so they will not pass, but they should compile. And then once you have this, then you can actually compile everything and try to make it work. Okay. So best practices. You can actually have like a best practices file, MD file, for the agent to read and tell it like, okay, after you generate some things for me, run linter and run vetting on the new code base if you're using Golang, or use this one if you're doing the Haskell. So then you can integrate it with your AI workflow. So you can say, okay, you can have this code reviewer role, and in the code reviewer role, you can tell it to read this sort of best practices file and follow like the linter and some of the checks, which you may want to do with the AI agent, or you may want to do just as a CI pipeline, and then again save some tokens. So the prompt patterns about who you are and how to run stuff. And then there are some anti-patterns, like if the scope is too big, if the context is not specific enough, and so on. So, those are skills that we have to learn, and those are kind of practices that we don't know yet. Like once you start doing it and practicing it, it will become kind of a second nature. But there is no one solution fits all. There are just sort of heuristics and kind of best practices. So, and also everything I know is from experience and from reading about it. And what I'm telling you may not be true next week. Like next week, we may come up with better ways of organizing it and doing things. So you have to be a little bit open-minded at the beginner's mind, and sort of be open to improving your process, right? Because many of those things are a little bit new to everybody, and we sort of just discovering how is the best efficient way of using those tools. All right, so it's always good to start with the minimum viable product, with the minimum use case, and then write specifications, let AI implement it, run the tests and integration tests, manually test everything and verify things, and then do code reviews and do your process reviews. The process reviews you have to do as a human, but the code reviews and some of the reviews, you can actually engage the AI to do the reviews for you. And then you only commit once you have this kind of definition of done. So once everything is good and everything, you are kind of happy, then you commit. With the hands-off approach, there is much more branching and much more commitment, because the agent is more independent and it will kind of do stuff, commit stuff, test things, and then go back and then update, like if tests fail and so on. And it needs to keep track of what has been done and when and why. So it uses Git for version control. In this manual mode, you are in charge, so you can kind of organize your chunks of work into small, logically organized chunks, and then do these iterations internally, and then commit after everything is happy, like everything is done, which usually works really well. If you want a little bit more freedom and a little bit more automation, then you will have to do branching and merging and kind of letting the agents do stuff and commit. But personally, I work mostly with the markdown files, and the commits I do manually. As I said, I try to automate some of the commits and some of the GitLab work, but it's like hit and miss. So sometimes it works really well, sometimes it does not work that well. And then, yeah, the bot says the each iteration should be deployable. Yeah, not necessarily. You may have some small chunks or work on small features, and then you may have like a streamline or some like a larger task, which consists of, let's say, 4 issues. And then after the four issues, it's deployable. That's okay as well. All right. So there is a little bit more about like mechanics of prompt engineering and so on, but I don't like, you can read it from the slides while you're working on the task. So I'm not gonna talk about it in now. What I will do is I will push the task, which is a word count task. And what we're gonna do is we're gonna use two coding agents. So we will use two coding agents today. One is called Gemini command line interface. Both of them are in the terminal tool, and the other one is called Open Code. This one is open source, and it is very agnostic to which LLM you will hook it with. So the LLM is of your choice. You have to configure it yourself and pick which one you want. This one is from Google, and it uses the Gemini LLM via the cloud integration, right? So this one goes to Google. This one goes to whatever you configure. If you use the same, if you will use GPT model, then you can configure both to use the same LLM, and then the experience will be similar because the LLM is the same. It's just that the agent is different, right? What's the difference between LLM and the agent? It's a little bit so if you have the agent talks to an LLM, but the agent has all these interactions with the tools and also with you. So it interacts with you, with your files, and with the tools. And for certain things, it asks LLM for organizing the prompts or organizing some sort of responses and doing analysis. But for some of the logic, it has this logic kind of built in and kind of interacts and orchestrates how the whole thing works. And the agent is sort of important because LLM is important for understanding the semantics or the responses and reading the like what to do and understanding your prompts and so on. But the agent is sort of the one orchestrating everything. And then depending on which agent you use, you will see that they orchestrate things slightly differently and your workflow is slightly different. And again, it's a little bit personal preference and you have to try things out. So that's why we kind of trying out two, which are for free. And then you will get a little bit of a feel. Eventually, of course, you are becoming productive in one. You sort of have your favorite one and just using that one. But when we're learning and when we're exploring, it's good to test kind of multiple ones. Same with LLMs. So this option is for free. And Google requires you to have just a personal Google account, like with Gmail. The open code is for free. You install it and then you start using it. And then you have to tell it which model to use. And as I said, for this exercise, you can just say, I want to use Gemini the same as for this one, such that the LLM is exactly the same. It's just that you're experiencing kind of a different agent, right? And then you have the commercial ones. So this is all for free. But if you want to try some commercial ones, unfortunately, you will have to pay. And for the course, I cannot make you pay or make you use it, but you may want to try things out. Like if you are sort of familiar with this already, like if you never used it before, go with the free version first. Like use it for a couple of weeks and don't pay. But if you already used it for a couple of weeks and you already know how it works and how to use it, then maybe you can pay it for like 1 month and experience a little bit better LLM, right? So there is Claude. Claude from Anthropic, they tend to have a really, really good agent, which is called Claude agent. And it also works similar way as the other ones. And they have their own LLM, which is fine-tuned to work with this agent, and the integration with the tools is like really nice. So I personally like it, and I find it the least annoying and like the most productive. There is Codex. Codex is from OpenAI. This one is a little bit more hands-off, and it has a very annoying agent, which is really dumb in terms of like working with grep and with Git and so on. It makes a lot of mistakes. Because the agent has to prepare the command line things for being executed, and you can see how it works, and you can see it misses the folder, it's in a wrong place in your file system, and so on. So this one kind of annoys me, and like I use it sometimes for planning, because the OpenAI the LLM from OpenAI is really, really good for strategic planning and architecture. It really is not that great for working with the file system and with coding, but it's really good for like finding out mistakes or analyzing code bases and like working with the architecture. So again, like there is no like a single solution that fits everything. It's sort of a choose and pick. So I do use it sometimes. I also have like a paid plan on this one, and it is really good for planning, like, and for strategic organization. This one is like the best overall for coding and doing other activities, like fetching stuff from online resources, organizing it, grouping it, sorting it out, and so on. I use it. I use the AI agents not only for coding. I'm using them for a lot of information processing and for research, for background checks, for validation and things like that. And they can automate a lot of things. I've been trying to use it for like finding deals as well. So you can say, I'm trying to buy something, and then it can go online, like prepare like a list of things and kind of periodically check if there is a better deal on something. So you can automate a lot of your life using those agents. So anyway, so those are the two probably top paid ones, but you have to have either monthly subscription, so you have to pay for a month, and then you can resign, or with Claude, you can also use the agent. So you can use the agent from Claude, but hook it up to a different LLM than the Anthropic one, and then you can have it for either for free or for a different fee. So I have used DeepSeek, the Chinese one. The DeepSeek has a very, very cheap plan. You kind of top up like for $5, and then it uses up your tokens. And you can hook up DeepSeek with the Claude agent in such a way that instead of using the Anthropic subscription, you're using this one instead. And then it's like super cheap to do some things. And the results are worse with DeepSeek, but they are kind of for certain tasks comparable. So for most of your things, I think you will not see much of a difference between the free and Gemini model and what this offers. But if your code base grows or if your complexity grows, then you'll start noticing that some of the bigger and more fine-tuned LLMs to work with agentic coding are actually better. But to start with, we're gonna do this. So let's have a 5-minute break, and then in the break, I will push the task into the course repository, and then you can start installing it, configuring it, and sort of playing with it. What we're working on is we're building a word count application, which given a file counts how many words, how many characters, and how many lines a file has. And it also calculates certain statistics on the frequency of the words occurring in the file, right? So that's the task. We're doing it in Golang and in Haskell, so we can compare Golang and Haskell. And we're trying to not code anything ourselves. So no code ourselves, everything done by the agents. And what is important is not, the important part is not the word count application, is how you organize yourself such that you make the agent work for you, right? So if you manage to get the agent do everything correctly and the tool actually works, that's great. And the sort of workflow that you design for yourself is the important part, right? How did you organize it? How did you organize your project structure? How did you organize your markdown files? What the agent reads and how the agent kind of generates things and how repeatable the process is, right? So the workflow is the most important. And then the second important is reflections. So what really worked, what was really easy, and what you learn that it sort of is not that easy and does not work, and you have to make an effort for it to work. All right, any questions? If not, then yeah, give me 5 minutes and I will push it to the repository and then you can start working on it. I will actually work on it as well to see how the more expensive models deal with it. Yeah. All right.